Hello. Here we go. Hey, it's the afternoon session, and I've got a little bit of a late start, but that's okay. My name is Rob. I am that developer dad. It is March 3rd, Monday afternoon. Now, this morning, we started a new small project, short stream series about how I have learned to and am continuing to learn to work with AI coding assistants. I've done some experiments over the past week and a half and had some fantastic results with those experiments. And I kind of want to take a few days to kind of document and snapshot my process here. So this morning, we started off with a concept, and I grabbed this image and I gave it to GitHub Copilot and said, hey, can you make me a browser display that roughly conforms to what's in this image? And we went back and forth for about an hour or so until we got the CSS approximately right. And then we started tweaking that CSS and getting things to a place where I was relatively happy with it by the end of that first hour. And then at the end of that, I said I would get the main work area container divided into 3 primary sections here. And I went ahead and did that. Now, in so doing, I noticed that I had some opportunities to properly separate out some of these concerns. So I spent a little bit more time working in the code editor with Copilot than I had planned to, but I got things really nicely broken out and documented and so on. So here's what the application looks like now. Give me a second. I'll just resize the browser window. Here we are. We've got our main work area is now subdivided into 3 panels. We've got an image editor, a palette editor, an image manager, and of course now we're putting some stuff down in the footer. Now to do that, I asked Copilot to subdivide the work area container into 3 subpanels. We would have 2 rows. There would be 2 panels side by side in the top, and then 1 long panel in the bottom. And it did all that. And I realized I think I would much rather have this be a lot more modular and componentized. So I said this, and I said, well, why don't we split this out into a number of folders and organize it a little bit more logically? So I've got a components shared folder, which doesn't have anything in it yet. It's going to very soon. And then we've got a features folder. Right now, the only feature is Pixel Editor, and that's probably the only feature we're going to have in this particular project. And it's broken out into components and lib. And of course, we've got our index.js. Now, originally, it only had this initializeEditor as a function in the index.js. And I said, I want to be able to initialize the editor, get the status information pushed into the footer container, and have our pixel editor sort of root class also hold the state that the inner components are going to need access to. So it made that change for me. It exports the class. I have access to initializeEditor, initializeFooter, and so far so good. We can see that it's rendering out right. I can still make changes. They show up automatically, courtesy of the Vite framework I'm using, and let's start thinking about some details. So I think probably the easiest part of this for me to reason about at this point in time is our palette concept. So let's go over to Copilot and say, I've changed the wording in the sub panels in the pixel editor / index.js file. I think we should name the panels for the text I've put in the spans. Their span labels. So let's just pop down here so that we can see. All I did here was span image editor, span palette editor, span image manager. Nothing fancy. And just like I've asked it to, you can see it as it's outputting its suggested edits. We've got ID image editor, ID palette editor, and ID image manager. Groovy. That's exactly what I wanted it to do. Accept. All right. Beautiful. We've got the descriptive IDs on them, and it's going to make it a whole lot easier to target those elements when we start bringing components in and managing state changes and stuff like that. Not just Copilot's asking, do I want him to add additional documentation about the purpose of each panel? I say, not just yet. We can add that documentation to the data, structure, classes, and JS components that will be added to those panels as we go. I think a logical place to start will be defining our palette concept. Each image actually, we don't want to start with the palette concept yet. Defining our overall data structure at a high level. The pixel art images we create will have a basic structure. We'll need to keep track of image metadata, name, dimensions, name and dimensions. We'll want to carry the indexed palette that is to be applied to the pixel map. we'll need an array of those index keys. Keep track of the indexed palette. That is used, that defines the colors in the image. We need an array of, we need an array to represent a pixel by pixel assignment of those colors to the image. Hey, what's up, Fern of Sigma? Yeah, Dad's got a LLM. Before you start suggesting classes and functions, please ask clarifying questions about these structures. I'm creating, okay, so the meta explanation for Fern of Sigma, the meta explanation is I am creating a series of streams of videos that document how I, as an experienced software maker, works with AI assistants to more efficiently create software. And some of the pitfalls that I run into, some of the advantages and disadvantages, and so on. This project that I'm using to demonstrate that process is going to be a pixel art editor, because I have need for some other projects I'm building to be able to create retro, old school looking pixel art, but I need the data that describes that forms the image to be as small as possible for, the economics of cloud storage, as well as the economics of transmitting potentially a large number of these pixel art sprites and tiles and textures and stuff across the internet as in as few bytes as possible. Now, I've been using GIMP to create textures and sprites and stuff, but the tooling in GIMP is really, really great for, larger, more complicated images, and it's not so great for simpler, older school constrained palette images and stuff like that. Yes, I do have a compression algorithm in mind that I want to try. I haven't researched any of the existing ones. I'm just going with one that I thought up while I was, doing other things. I was like, I wonder if this would work. So we're going to find out. We're going to try it. And if it works, I think I can get a 75% reduction on the byte length of a image that has a constrained 16 color palette. We'll get there. Right now, I'm just getting the visuals and the layout and some of the data structures in place. So we're not going to have a lot of visual change during this session. I want to try and get some basic data structures going. So image metadata beyond name and dimensions, creation data last modified, dimensions have maximum limits. Do we need to validate the image name format? Okay. Image metadata. Dimensions should be constrained to powers of 2 with a maximum height width of 128 by 128 pixels. The image name should contain only alphanumeric characters plus single dash and underscore. I don't see a need to capture any other metadata. The color palette. We will constrain all palettes to 16 colors. The color defined at position 0 will always be static and represent the default background color to be used on the image. The other 15 colors will be editable and will support any of the RGBA palette. RGBA colors. Each palette will have a unique name. We will offer 2 built-in palettes to start with, but let's get the data structure down first. Pixel data. Pixel data. Single dash and underscore. Pixel data. Let's go with a 1D array. We can split it into, we can implement a blit function to push the pixel data into the canvas. Later on, we'll have the image dimensions stored in the metadata. Dimensions should be constrained to powers of 2 with a maximum height width of 128 by 128 pixels. In this first iteration, we'll go only with square images. Height equals width. Separate classes that compose together are one main class. Any validation or error checking for these structures. Okay. General structure. I think separate classes make sense. We'll need palette and pixel data available in several components of the pixel editor. I think separate classes make sense, and we can compose them into the overall image state class. As far as serialization and deserialization goes, we'll need that on some of the properties, but we may not need fully hydrated forms of some of the classes. Let's get the skeleton put together. First, just with simple JavaScript classes properties, and we'll fill in the details as we go. Let's let my buddy Claude chew on that novel. Now, I believe I've already got a pixel editor /lib. Features pixel editor lib. Here we go. It's empty. So what I'm going to do is copy that, paste, and go. Now, let's take a look here. Did it create anything for me? It did not. Okay. Those terminal commands didn't work. I'll create the files manually. All right. I'm going to keep index.js. I'm going to close CSS and this image file. I've got the file names over here. So in lib, new file, and it's going to be called Palette with a capital P .js. Another new file called pixeldata.js. Another new file called imageMetadata.js. And finally, imageData.js. Let's go back to Copilot and see what they say. Class definitions one at a time. All right. Let's create image data or image metadata. Do it. Save. Beautiful. It's got param string name. Okay. Name untitled, size equals 16. I'm going to change the default size of the on image metadata to 64. We should provide discrete height and width properties, though, so that changing to rectangular images later isn't a cluster pluck. Let's see how it reacts to that. It might update the default size for me. Yeah, that'll do. Accept. Okay. Name equals name. Okay. Let's start defining these other classes first. There's no need to update anything. Those class files are currently empty. Save. That's a good start. We'll edit it after we get the other pieces put together. And Claude wants to know if I want him to proceed with the image state. Yes, please. And you'll notice that he's using JS doc format for all of these comments and everything like that. That's because earlier in the conversation, I've asked him explicitly to maintain clear, concise, but proper documentation practices. Excuse me. Okay, static create new. Title width 64, height 64. Palette, okay. And file, save all. Okay, it composes all of our data structures together, provides default initialization, includes a static factory method for new images, maintains proper dimensional consistency, add import statements, validation methods, serialization methods, something else. let's add import statements for the dependent classes. And I didn't apply. Here, stop. I just realized I didn't apply this to the image. Here's image data. Here's pixel data. Where's image state? I got to rename this to image state. There we go. Duh. Now let's apply it and save. Okay. Oops. I realized that I had not applied your edits to the file for imagestate.js. Let's add those imports now. And while it works, so the compression algorithm that I've come up with is sort of a combination of, hey, Ercamus, is really just math. Because these images are all going to be dimensioned on powers of 2, so 64 by 64 or 32 or 128 or whatever, we can divide them into groups of 4 pixel elements. And then because I've constrained my palette to have a maximum of 16 discrete colors that are used within the image, I can take those groups of 4 pixels and compress them down to a single character or a single byte value, which means I can take a 64 by 64, that's a whole lot of pixels, and reduce it to whatever 64 divided by 4 is 16, about 16 to the power of 2, so 256 bytes, plus a little bit of metadata. So that will make me very, very happy. All right. If my algorithm works. And it's going to save me a ton of storage space and a ton of bandwidth, because bandwidth is going to matter an awful lot with what I have in mind for these image data objects. So we've got the metadata, we've got our palette, and we've got our pixel data. I want to rename pixel data to pixel map. Oh yeah, I'm using the dreaded JavaScript, and I'm using Copilot to do most of it. Pixel map class. Let's just go new file. Save that. I'll delete pixel data. Update the imports on image state. Accept. Okay. Now, come out to my files. Let's get rid of pixel data. Delete. Move that to trash. Pixel map. I want to define pixel map. Stores color indices 0 to 15 corresponding to palette entries implemented as a 1D array for performance with helper methods for 2D access. Groovy. And I'm going to say 0 to F. Yeah, that's about it. And then image state. There we go. And let's go over to palette. Name class from pixel data to pixel map, updated the file name, all references in image state, updated parameter and variable names, maintained all existing functionality. Great. Let's now focus on the palette class, which will need an additional class for support for UI support. The elements in the colors array should all be valid 8 hex digit color definitions with 2 hex digits each for red, green, blue, and alpha. When we serialize a palette, we'll output its name and that array of hex codes. This dot name, this dot colors. Good. From JSON data. Perfect. Let's apply that change. Accept. Now, in the components, add a new file called PaletteEditor ViewModel.js. color picker ViewModel.js, and another one, swatch editor ViewModel.js. Great. I've added 3 new empty files to features/pixel-editor/components to represent the view models that will build up displays for a palette instance. Starting from largest to smallest view model file, let's get their properties sketched in. Let's see how you do with only the current information in your context. I want to see how Copilot does. Okay, so Copilot can infer that I'm building a UI hierarchy for palette management. Start with the largest view model. It didn't get it right. Index hex color is locked. Not quite. You didn't quite hit the mark there. Let's go over the 3 new files and my intent. PaletteEditor view model will receive a palette instance. For each color in the palette instance, it will create a new swatch editor view model that will hold the color array index and hex code for the color and make that color editable or not. The color picker view model will also accept the palette object and be display only. We'll work on that last. Changes made to individual color swatches should immediately update the underlying palette object, which should then automatically update any visuals that depend on that palette instance. Should probably change the view to PaletteEditor, but that might confuse it. We'll see what happens. Oh, here we go. Creating the PaletteEditor view model. Beautiful. We've got export class, PaletteEditor view model, param palette, receives a palette, creates an array of swatches, selected swatch index is -1, initialize swatches, index color, and then that determines whether or not it's locked. Okay, I think I need to come back up to Swatch Editor and actually apply these changes that it made. So we'll save those, pop down to PaletteEditor, incorporate those changes, save it. Cool. Update color, boogity boogity boo. Index new color. Palette, okay. All right, update color, new color. Is lock, return false. Okay. In the swatch editor view model, I also want to allow color configuration using numeric decimal values for each component of the color. Red, green, blue, and alpha. Those numeric values should be constrained to a range from 0 to 255. When any of those component values are changed, the hex color should be recomputed. When the hex color is edited, those R, G, B, and A values should be recomputed to match the new hex color value. Beautiful. Boom. Accept. I like it. Two-way sync between hacks and component values, range validation for components, proper locking behavior, clean interface for both hacks and component editing. Awesome. For the visuals on this view model, do you think it best to create a discrete swatch editor view.js file, or embed a function into the view model that emits the HTML to represent the functionality here? Single responsibility tells me I should have a discrete file. And Copilot agrees. Rendering and user interaction makes future UI changes simpler. The view can be reused in other contexts like a color picker. Different views can be created for the same view model, makes it easier to create different themes or layouts. Complexity management, yada, yada, yada. Beautiful. I like it. New file. Bam. Save. View model, container ID. Okay. Render, attach event handlers. I like it. Going to need an import on that swatch editor view, aren't we? All right. Accept that. Groovy. Control S. IntelliSense can provide proper completion, properly linked, we maintain clear dependencies. Let's get the render function defined. For this component, I'm visualizing a single row with elements in order from left to right. Index, hex color, text box, R, numeric text box with spinner. Oh, for crying out loud. I hit enter instead of shift enter. Before I could specify G, B, and A fields. Please add those to the proposed function definition. Okay, there's this. Accept. Save. Okay. Let's actually get rid of the labeling on those fields. The PaletteEditor will provide a header row for those fields instead. We need to make sure that the resulting view doesn't use up too much horizontal space. Apply. Okay, so what we're doing here is we're just creating the JavaScript that will render out that view model to a screen. Cool. Let's get the CSS stubbed out for this. And I need style.css. I'll come back to Copilot here. Inline styles to proper CSS classes. Good. 20, 80, 50. Those might be a little fat. Because right now we're looking at 100, 300 pixels wide. After the swatch editor view to you see, okay. Let's get that going. As a new file. Save it. Go down here. Update this to import that specific CSS. Accept. Save. And let's make sure we have both of our imports. Good. Good. Type number, class, swatch green, swatch blue. What's going on over here? Swatch hex. Nah, fine. I don't think we need the discrete swatch color CSS classes. Swatch editor, swatch index, swatch hex, monospace, uppercase, yep. Color components, yeah. Apply, accept. We'll update the view and accept. Save. Okay. Now, I realize that I'm above an hour, but I really want to try. I'm going to close the color picker view model for now. We've got our swatch editor view model. We've got our swatch editor CSS. Let's just save all. Now, we don't have any visible changes out on the UI yet, but let's see. Image metadata, don't need it. Pixel map, don't need it. Image state, don't need it. Swatch editor CSS, we'll get rid of that. We'll keep swatch editor view and view model. We'll keep the palette editor view model, PaletteJS, and index.js. Now, let's update the palette editor view model. With whatever changes we need to make to use the swatch editor. Updated swatch editor view model. Hey, right on, Urkamus. Thanks for hanging out, man. It's good to see you again. Let's keep the visuals out of the view model classes. We'll do the render thing next in a palette editor view that we'll create once the view model is in good shape. All right, let's see what it wants to do. I don't really see a whole lot of changes. Right, next, color to update. True if update was successful. Okay, select a swatch in the palette. Okay, let's just see what it changes here. Well, it's making some changes. And accept. Save. Groovy. Okay. Added swatch editor view model import. Added selection management methods. Maintain existing color update. Added getter and setter for, or added getter for selected swatch. All right. Let's stand up the palette editor view. Now our palette editor view model also has the palette. Good. Palettes are model. Remember that. Div class palette editor, header index, IDX, hex, components, RGBA, good. Swatches container, beautiful. Reference to swatches container. We rip through our view model for the swatches. Yeah. Attach event handlers. All right, let's bring this in. And we need a new file for this. Save. Here's corresponding CSS. We'll add it to a new PaletteEditor.css file. Cool. Key features, blah, 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 blah. Actually, let's get a couple built-in palettes created in the lib folder and start integrating the work we've done with the main index.js. What's it doing? Still thinking? Yeah, it's still thinking. All right, let's come over here, hover over this, and we'll add a new file, code source features, pixel editor, lib, built-in palettes. And we've got a grayscale palette. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Beautiful. And then a basic RGB palette. Yeah, that'll do. That's fine. Save it. Cool. Now we update the main index.js to use our new components. Yep, let's do that. Boop. Accept. This dot built-in palettes, create grayscale, create basic RGB. This dot active palette equals this dot built-in palettes. Okay. We've got a change. So we've got all this stuff. Cool. So we can see the palette over here. Nice. Let's pull this over because I feel like it did something goofy with. Okay, so we've got our active palette grayscale. Good deal. Initializes the editor interface. Cost palette VM. Host element ID. Okay, so an issue we have here is that it added the palette editor to the main workspace. Built-in palettes with 2 common color schemes. Okay. First off, let's get the palette editor view loading into the correct panel, which we lost in that prior update. Remember, the index.js file lays out the contents of the work area container and has an image editor, a palette editor, and an image manager panel. The palette editor VM view model needs to go into the palette editor panel we used to have. Okay, now we can create the main layout. There we go. Much better. Go. Okay, let's accept this. Save it. Hey, look, it's back. Sweet. Fantastic. Let's add a title row in the palette editor view. It'll hold a static label and a dynamic static label, a dynamic value for the palette name. Hey, I'm over here, robot. This is the last tweak I'm going to make to this before I call it a session. One thing that I am going to do offline is I'm going to shrink the size of the palette editor panel so that we can get rid of all of this white space here. And maybe shrink the widths on these fields because they don't need to be that wide. All right, palette editor, palette title, current palette, class palette name, this.viewModel.palette name. Beautiful. Do it. Accept those changes. Bring up my amazing pixel art creator. Come over to code. Actually, I'll pull this over to the other monitor for a second. File. Save. Here we go. Current palette grayscale. We see the whole thing on screen. Great. And we got to update the CSS. Accept. Save. Groovy. I like it. Okay. One last change for this session. It's actually 2 small changes with 1 goal. 1, let's shrink the field widths in the swatch editor view so that we don't have the up-downs. That's fine. So that they have enough space to show a 3-digit number, but aren't too wide. Okay, swatch hex is 70, 35. Update that. We're going to need to update the corresponding widths in the palette editor as well. Good call out. I'll accept those. File, save all. That's much tighter, you can see. Groovy. Awesome. That's much tighter. Now, let's make the panel that holds the palette editor sized to contain that editor and leave the rest of the width of that row for the image editor panel. We use, let me see if I can find the right one. Use the style.css file that's been set up in feature/pixel editor for that. No, that's not what I wanted to do. That's not what I wanted to do. Let's close PaletteEditor. Close the swatch editor. Let's shrink this down. Close these JS files. Close that. We've got index. Style. Bam. Not what I wanted to do. I want to set up the panel layouts that are declared in index.js, but none the imported components in the style.css in the same folder. And I don't think there's any sense in me making y'all watch me argue with with my assistant while we get it to make the changes in the appropriate places, but you can kind of see where I'm going. I've got some inline styles in the HTML that gets emitted for these three panels in the JavaScript file. And I want to move those inline styles into the styles.css that's scoped to the pixel editor component, or the pixel editor feature, I should say. So let's see what it can do here. Flex column, flex row, we've got those. Panel middle, image editor, palette editor, image manager. Okay. One thing we've got those dot flex row dot flex column dot panel middle classes defined a level up we should import the base style.css layout.css from where it lives. Let's define only those styles that exist within the pixel editor scope. And this is going to be what I go on with offline here. I'm going to get that palette editor squooshed over to the right and free up a lot more space for the image editor in between now and tomorrow morning's stream. So you can see that we made a ton of progress this afternoon. I'm quite happy with at least the visual representation of this palette specification. And once I get the color picker view and view model created and placed in the image editor, we can start thinking about some event handling and updates and so on and so forth. But we'll get into that stuff tomorrow. I'm just going to get more layout stuff done. I might actually do the image editor layout while I'm offline here. But I won't get too far into it. We're not going to get into canvas manipulation or any hardcore algorithmic stuff offline. I'll save that for the streams. But I'll probably continue with with getting the layout and the visuals correct between now and tomorrow morning. So until then, I am Rob, that developer dad, and I wish you all a great rest of your day and happy coding. Take care.